The next question that we are trying to solve is minimum moves to capture the queen. In this question, we are given with an 8x8 one-base indexing chessboard. Okay. Along with that chessboard, we are given 3 pieces of the chess that people play. Right. The 3 pieces positions are given in the form of A, B, C, D, E, and F. Okay. Where A comma B is a position of rook, which is of the white color. C comma D is the position of white bishop, and E comma F is the position of black queen. Okay, these are the initial positions of white rook, white bishop, and black queen. Now here, both white rook and white bishop try to attack the black queen, right? And it is given that the black queen cannot move from its place, right? The black queen will be fixed in its position E comma F, and we should find out the minimum number of moves required to attack the black queen, right? Looking at the constraints are straightforward. All the values of A, B, C, D, E, F will be in the range of 1 to 8 because chessboard is in the range of 1 to 8. It's a 8x8 chessboard. So with this information, we have to find out the minimum number of moves in which we can attack the black queen.
So before moving on to the solution, let me just explain how a rook, bishop, and queen moves. Okay. So if we have a rook, basically, we also call a rook as an elephant as well. So if people who are familiar with that will understand. So a rook can basically move to any position on its row or to any position in its column, right? So those are the moves rook can make. Now, about a bishop can move to any position in its diagonal, okay? And any position in its diagonal, covering all the 4 diagonals, okay? So like top left, top right, bottom left, and bottom right, okay? Now, and the properties of queen here does not matter because the queen is fixed in its position. So queen is not moving. So the way queen moves is not relevant to this question, okay? Now here I'll just write bishop as B. Okay, I'll write bishop as B, rook as R, and queen as Q. Okay, and this is a 8x8 grid. All right. So here, let's say the bishop is present in the same row as the queen. Okay. Then it's always possible for bishop to go and straight away attack the queen, given that the rook does not. I'm sorry. This was supposed to be rook here, okay? Because bishop moves in diagonal way. So if a rook is in the same row as the queen, it's always possible for the rook to directly go and attack the queen, right? Unless there is a bishop in between. In that case, it would not be possible to directly go, okay? So we can define some conditions like this, all right? So we can say that if the queen is present, okay, basically if the queen is present in either the same row or the same column, okay, if the rook is present here or here, just any part in this place, basically any row or in the entire row where the queen is seated or in the entire column where the queen is present, if rook is present in the same row or column, then it's possible for the rook to directly attack the queen. But in case if the bishop is present in the middle of those both, then it's not possible. And how do we make a check for that? So basically, if we have the bishop here, okay, and if we know that the rook and the queen are present on the same row, then we know that the column number of bishop will be between rook and queen, and the row number of bishop is also equal to the row number of queen and rook, right? In those conditions, it's not possible for rook to directly attack. So in that case, the number of moves will be 2, because bishop can basically slide either up or down, giving rook the ability to move. Okay, so bishop can basically move somewhere so that the rook can go and directly attack. Okay, so in the case where bishop is coming between the rook and queen, in that case the number of moves will be 2, or else if it's not coming in between, then the number of moves will be 1. Okay, now let's see the cases for bishop attacking directly. Okay, now these are the cases for rook to be able to attack directly. Okay, now for bishop has to be present in either the same diagonal that goes from bottom left to top right. Okay, let me just make it like this. Either it has to be present in this diagonal, or it has to be present in this diagonal. Okay, so when we have a grid, there are two types of diagonal: one that goes from bottom left to top right, and one that goes from top left to bottom right. Okay, and if the bishop is basically present at any point along this diagonal, then it's possible for bishop to attack the queen. Okay, now here it's also possible for bishop to attack the queen by being present somewhere like here. Okay, so basically the bishop can take a move, come at this point, and then go and attack queen, right? So that will take 2 moves, right? But we see from the previous case that anyways it's possible for us to attack the queen with the help of a rook in 2 moves, right? So for this, for the sake of this question, we'll not be discussing that point, because anyways it's possible for rook to attack in 2 moves. Okay, so we'll only take the case into consideration where the where the bishop can attack in a single move. Okay, now the bishop can attack in a single move, right? And that is only possible if either of it's present on either of the diagonals. Okay, and even if, let's say, here we can have the same scenario. So let's say our bishop is here and our rook is here. Okay, so bishop can basically attack the queen straight away, but rook is coming in the middle. Okay, now we can also tackle this in a similar way. Basically the rook can move aside, and then bishop can attack the queen, but again it will again take 2 moves. So let's just ignore this case completely. Okay, so what we do to solve this question, first we'll find what's the minimum number of moves required for bishop to attack the queen. Okay, now that answer can either be 1 or 2. Okay, if it's 1, we can straight away return 1, because it will never be possible for us to attack the queen in 0 moves. Okay, but in case the answer for, okay, this is rook, right? Okay. In case the answer for uh, uh, rook to directly attack the queen is 2 moves, only in that case we check what is the minimum number of moves required for bishop to attack the queen. Okay, and if bishop is present in along the same either of the same diagonals, then the answer will be 1, or else it will be 2. Okay, and how we check that whether the bishop is present on the diagonals, right? For that, what we can do is, basically every diagonal has a property. Okay, if a diagonal is going from bottom left to top right, then every cell present in this present on this diagonal will have a unique sorry, I'll just write row comma column, row plus column value. Okay, so the row plus column value for this, the row plus column value for this will be same every single time. Okay, so if you observe here, this is present at 4 comma 7. Okay, this is present at 5 comma 6. So 4 comma 7 or actually it's 7 comma 4, right? 7 comma 4 and 6 comma 5. So 7 plus 4 is what? 11, and 6 plus 5 is what? Again 11. Here again 6 plus 5, 11. Here again 4 plus 7, again 11. So elements present in the same diagonal, which goes from bottom left to top right, will share the unique value of row plus column. Okay, So if you want to check whether the bishop is on the same row or column, we can just use this formula. Find the row and column value of Q and find the row and column value of the bishop. Just compare if they are equal. If they are equal, then they are present in the same diagonal. For the other diagonal, which goes from basically top left to bottom right, okay. For this diagonal, we have again another unique value, which is r minus c, okay. So this r minus c will be unique for all the values lying on that diagonal, okay. And for other diagonals that are going from top left to bottom right will not share the same r comma c. So yeah, you can do these two checks: r minus c for this type of diagonal, and r plus c for this type of diagonal. Okay. So yeah. So yeah, the conditions are clear, but writing the code part might get a little bit tricky. You might have to handle a lot of cases. But yeah, basically this is how we solve the question. And the time complexity for this will just be O of 1. It's just O of 1. And phase complexity will also just be O of 1. Okay. So yeah, this is how we solve the question.